Hello everybody, and welcome to this short video illustrating the MOS user interface. So, the user interface is automatically generated when a model is uploaded to your local or cloud instance of MOS. And the model representation is built up from the source code of the model itself and also comes in the model file. So, we're going to just take one of this example problem and work through that and to illustrate the interface. So first of all, we can look at the source code. So this is just a CVXPy model file from which this model representation is built. I don't want to focus on the problem itself, but on the interface here. But just to give a little bit of context, this problem is a portfolio allocation problem where the vector of decision variables, W, represents a fraction of the portfolio allocated to each stock. And the optimization function being maximized here is return less weighted risk. Okay, so just to give an example then of what we can do, first of all we want to get our inputs. So we can specify our input data file. We can our weight of our risk aversion parameter, and what we call here, we'll just say our leverage limit. Great. So now we can see we have our inputs all uploaded. And before I press model run, I'll just mention helper objects, which are tagged in these items are tagged in the code as helper objects. And these are items that maybe do some computation on top of the input parameters, or through some parameters that could be hard-coded in the file if the user so wishes. And these are helper objects we can view and are available then to the optimization solve itself. So we can click run, and so this does the model executes. So the run button executes the whole model file. So these helper objects are parameterized, and also then we can look at our model variables, function constraints, and see and just see the outputs of the model. What was the function values, variable values that reached the optimal solution. And so we can see some features here of the whole W vector. I'm going to come back to that in a moment. So the functions in the model, the return function, the risk function, the objective function, of course. So these all return scalar outputs. And the constraints. Now this is important that we can see the dual variables associated with each constraint. So in this case it was the sum of fractional allocations must equal 1, and so we have an associated dual variable to that constraint. Similarly, leverage in this case was just that the norm of the vector must be less than this leverage parameter with one of our inputs. So again, we can learn some information about a constraint, see the dual variable associated with it at the optimal solution. Then in our problem, some things about the problem that have been picked up by MOS. So we can do convex problem, size of the problem, and some information about the solver. So if a helper object is tagged in the code post solve, we can use that too. So that's pre-opt is the helper object pre-opt, and post-opt are the helper objects post-opt. So this one is just to condenses the output into a more human readable form. So for example, we can see amongst the 100 stocks that were in our 100 toy stocks in our data, we can see stocks 28 and 32 had, for example, stock 17 higher allocation than others. So this was again, you can define your output helper objects in whatever way suits your use and problem at hand. We can also define output files. So here's one I actually had. So for example, the allocation. This was actually from a previous model solve, this particular image, but just to give an idea of what we can do here. And then we can also just check the execution log. And finally, there with this representation, this is just a core representation. So now you can run your model, see outputs, change inputs, and this functionality is all automatically generated once your code is prepared accordingly. So we're going to have separate videos on annotating the code to work with the current version of MOS, and also doing every click we did here in this video can also be done via API, which facilitates machine interaction with the model and different programs in your software stack. Also, with this representation, we can build on top features like analysis of model solutions, automated interpretation of optimization outputs. This would be under the analytics tab here. We're still building out that functionality. Also, model snapshots. We can, perhaps for regulatory compliance purposes, this would be helpful, where you can keep a log of model run, the date time the model was run, what were the model inputs, what were the model outputs, and maintain a snapshot of particular model runs that are particularly relevant for the purpose of the model, for the organization who's running the model. So that is the user interface overview. I want to thank you for your attention and joining us today, and look forward to seeing you in future videos. And finally, of course, just if there's any questions or information you'd like to follow up on, please, we'd love to hear from you. Thank you.